I sent the recording yesterday. So today
Yeah.
also.
No, once you send the today also, no, we
Okay.
go download both the session by end of
Right.
it.
Right. Okay. So the next is so a priori formula, a priori thing is somewhat we got familiarization. The next is plus 10 expectation is ECLAT. So we have to see the ECLAT methodology with the same ideology of association. Okay, so I will open up the.
Yesterday, see, I have one question.
Hmm.
You showed that code, na? So what is the what is that interception from the output? So how do you see the results? Like we just sorted out the outputs and everything.
Right.
And how do you interpret that result?
Okay. Let's see. Wow. So first we'll see the a priori methodology.
And we see some calculations, right? Support,
Right.
the
Right. Right.
confidence and lift. These are all the key terms in a priori they are using. Okay.
Yes.
So
Yes.
our algorithm, actually, we are using a priori algorithm to get the
Right.
results. So
Right.
what is happening is after running that algorithm, there is some results are coming, and
Right.
we are sorting out the data set. So how
Hmm.
do you interpret the result from the
Okay.
algorithm?
Okay. Okay. So if you see the result, so if you apply all the things, and if you, I mean, after applying all the the respective algorithm, and also the the minimum support and the confidence level and the lift and the length and the maximum length and everything, you are getting some association. Before that, we don't. I mean, if you see the data set, it clearly shows that it has lot of information. That is one thing. That is unstructured, unordered, and unlabeled. These are all the basic information we should know about before proceeding with. After applying this algorithm, it is slowly it is getting some association with the item numbers. If you see this table, because it is very clumsy, this information is clumsy. That the raw result is clumsy, so that they are putting in a tabular format.
Mm.
If you see that tabular format, left hand side, the light cream, if it is there, the right hand side immediately the chicken should be placed. This is the association. If this has been placed, that shelf or that supermarket will sell more products. That means chicken is always associated with the cream, not in India mostly. Nowadays, it is also coming into practice, but in Europe and US, those countries, if they buy chicken, they always go for the cream or sauce. Okay, so that is the because this food is not maybe in our age, maybe this is not really you know um, uh, I mean familiar usage of our day-to-day life. Our South Indian dishes is really different. So if you see the escalope and mushroom cream sauce, this has an association. If you see escalope and pasta, this has an association. Honey and uh, fromage blanc,
Okay.
this
So
has an association.
from the data, it automatically calculates the association. So based on
Yes.
the number of transaction happened
Yeah.
particular data, it is automatically taken. Okay, okay.
Yeah.
So on
Automatic.
the in
So.
the yeah,
Mm.
is it like a 10 transaction or a 50 transaction? We can only see millions of transactions. It's very difficult to yeah,
Exactly.
yeah, I agree with that. So okay. So
Even in
that time I
our
think this algorithm.
yeah right. Even in our data set right now, we
Mm,
couldn't find any kind of relationship because the data is somewhere sitting.
mm,
There is no. We couldn't see through our human. I mean, naked eyes.
right.
So that is why we are putting that into a priori training, and after the training, we will be able to do this kind of. We will be able to predict, not
Mm,
we'll be able to predict this would be the association, and we have to set along with this association. We have to format this kind of information. I mean, with the usage of these results, we can just change the rule in our supermarket. So that is
Okay.
what the implications.
And on a data frame you are trying to put now. So what is
Here,
it
yes,
actually? The left hand side, right hand side. So this is the data frame we are creating. So the final results it will be so in the form of data frame. So in
right.
that,
So, mm,
the many things are there, right? Tuple that we read it in the Python initial stage.
yes,
So
yes,
tuple.
yes, yeah. So
Um,
you have
mm,
to freshen up, brush up those knowledge, because people, once you created a tuple is nothing but it is a list. It is also a
mm,
kind of the value. But in tuple, if you are just reading one value once, you cannot modify. So that is why we are using tuple. Otherwise, we will be using list or a set or any dictionary values. These four, okay, I will show you this. This, becomes not table of set list.
You're sharing something?
Yes, I'm sharing the chat GPT.
oh,
No,
it is not showing.
you're not
Okay,
sure.
no problem.
Maybe alternate screen you is.
Is it visible?
Yes, yes.
I was asking, the chat GPT to put it in a tabular format of set, list, dictionary, and tuple differentiation, because these three, I mean, these four things are very important in data structures
Mm-hmm.
in Python. Okay. So if you see the set, list, dictionary, tuple is an ordered collection of items, but it is immutable. Immutable in the sense it is not editable, modifiable, or whatever. This is called as immutable. Mutable in the sense you'll be able to edit in future. So this is what main difference, and this is ordered and it is indexed, and it allows duplicates as well. Okay, and you have to be make familiarization with this table. Maybe you can also ask, or I will send this table format if you want. I can share. I will be able to share this conversation. Yes, I've shared through WhatsApp. Okay, so no direct methods for adding, removing, whatever you want. Only the read operations. Faster than list for reading operations. Useful when immutability is needed. Immutability means you won't be able to edit. Suppose this screen is visible.
Yes, yes.
Yeah. So if because we are dealing with data, the raw data, so we don't want to try using a lot of information. So once you run, it will take it will consume your power, it will consume your hard disk space and everything. So what we have to choose the right method of adding the value. Adding, I mean, what they are doing, they are just uh, through the indexing order, they are taking the column names. Okay, so the column names, and also the left hand side, what would be the column? The right hand side. I mean, if they are saying the columns, they will be going with the index value. So you know how Python is working. It starts from zero. From left to right, it starts with zero. From right to left, it starts from -1. Right. So I mean that is the other thing you should know. So you have to to just make it as a very customizable tabular format. We are making it as a readable format. So LHS, RHS, and supports what are all the supporting elements and how the result is, and how we have to compare with the support, confidence, and lift, so that we can make some kind of an association. So whatever the rule we are getting with respect to LHS and RHS, okay, so we will be able to do the comparison, because we have to check whether this algorithm is working or going in the right direction. So we already know about support, confidence, and lift through this, the calculations. Based on that, we'll be making decisions. Okay. So
If it is showing a positive value, then there will be a probability of what is that associations is there. If it is going is there any negative value will come?
we need to check. We need to check. That is why I asked you to search for maybe what I will do. I will give you the how this is. So everybody, during the beginning stage, they'll be taking the market basket analysis. The frequency they will be seeing different settings, the second task, and just take some of the other information. We want one first. And, first. This is all of the uncovers hidden structures in categorical association to learn. This. This really is. This is also a same thing. Eggs, bacon, soup, eggs, bacon, apple, and we are just making some of the informations. Maybe you can also try. So this is from MIT. MIT license data, and you can go with this. You can try, but then only you'll be able to different points of a perspective. Okay, so what I will ask after algorithms is for this is about mining. This is some kind of a data.
But one thing I observed was like associate learning. This majorly is used in e-commerce and market sales only.
Okay.
I tried searching for any other implementation of this particular thing, but I apart from these two areas, this was extensively used.
Okay. Yeah, might be, that is the case of, the a priori algorithm, and one more thing, the ECLAT algorithm. For recommendations engine, the other sentiment analysis engine, this would be the very basic rule learning methodology. So that is also there. Right? So here they are using for data mining. So you can also get into this. They have it's really a different activity. You can try. See, in artificial intelligence, whatever the proven techniques, whatever the proven algorithms, whatever they have already proved, like the transformer algorithm was already there, but after ChatGPT comes and proves that it is possible making a large language model, you can retrieve, and the responses would be more or less equivalent to the human, like a human response, and then everybody is using transformer. Okay, so this is the case in artificial intelligence because we have to because this needs a lot of budgeting, needs a lot of infrastructure, and everybody would be waiting for something would happen. Say for instance, even association rule learning also in the basic machine learning, there will be everybody going for this kind of an analysis because it's already proved and it is very effective and this potential. They don't want to go and test it for the new approach. Okay. So that is also one of the cases, so that yes, we are in the safe zone. But it would be the starting point of a lot of other algorithm which we are going to study in future. So you can also try and search for these kind of things. Yeah, they have a lot of things. Yes. Maybe you can also explore and try doing this, especially for API. So we already explore. So we will be doing the ECLAT because ECLAT also it is associated with this. Only the formula will be a different one. Here, yeah. So this will be the different formula. I hope my screen is visible.
Yes.
So the ECLAT, maybe I will open the code from. So this is the ECLAT code which we are having. It is the same kind of an approach. Only the methodology is changing. Where the methodology is changing, right? You need to identify where the ECLAT is changed.
We are using a priori only, right, Asini? That is also
Yes,
a priori only.
yeah. This is also that is why in the same kind of information they are discussing with a priori the same kind of APY ORI library. In this, the data pre-processing done and the same training the ECLAT model. They are also importing the a priori model only, but the rule slightly will change. So that is what we are going to see about. So where the ECLAT, because they are saying that training the ECLAT model and how it is different from a priori. Okay, let's see. So ECLAT algorithm stands for equivalence class transformation. Equivalence class transformation. That is the abbreviation of equivalence class transformation. That is ECLAT. So while the a priori algorithm works in a horizontal sense, imitating the breadth first search of a graph. So this is what we already um, seen in the a priori algorithm. Breadth first search of a graph. The ECLAT algorithm works in a vertical manner, just like the depth first search of a graph. So what is breadth first and depth first? So we'll do this breadth first search and depth first. Let's see. I hope my screen is visible. Okay, so this breadth first is was referred to the a priori algorithm, right? Right. So BFS explores the search space level by level. It starts by generating frequent item sets of length 1, then moves on to item sets of length 2, and then length 3, and then so on. Okay, so a priori algorithm is a common example that uses BFS. So if you are using a priori, automatically the breadth first search in association rule learning. And how it is just goes, it is going by level. How Python is running or executing the code line by line. The same will be explored by the code has been the columns. Okay, it is, and also the length just moves one by one. It is not just jumping one to another. Okay, so a priori generates a candidate item sets, possible frequent item sets of size k plus 1 by joining frequent item sets of size k and prunes. Data pruning already we have seen in one of our classes. Prunes them by checking against minimum support thresholds. So support is we already gone through the minimum support thresholds. So this a priori algorithm, it is just going through one by one process or level by level, and also the item sets of the column name, length 1, 2, 3, and so on. And that is how the rule for a priori, and that is how the rule for BFS, the breadth first search. Okay, so it ensures that shorter item sets are always explored and pruned before moving to a longer list. So easily prunes up unpromising paths early on by leveraging downward closure property. If an item set is infrequent, all its supersets will also be infrequent. So if you just compare with infrequent and frequent data sets or item sets in any of the manner, if you see in any e-commerce portal or even in the physical stores of common departmental store, this is what we discussed yesterday. Some items, it will not be infrequent. So that means they are planning for something else. They are planning for marketing something, marketing new products from the same brand or same company, right? That is, they just slowly stopped the frequency of the products. A disadvantage of using a priori may require a large amount of memory, what we've seen, especially when generating large number of candidate item sets at each level. So for each and every level of information, you have many associations. Okay, I think that is what, if you see here also you can see. If you see the results, you can have this is the vertical. So before what we have seen, but that was a horizontal level. So in an horizontal level, how it can be associated, it could be many things. For one product, you can have multiple associations, and that is what the power of association will learn. Okay. So DFS, depth first search, explores a complete path in the search space before backtracking and exploring alternative paths. Okay, so it won't go through like it is not in order. It is just if it is proceeding or executing, it is not level by level or it is in order. It is always backtrack the information and try to explore, is there any other alternate paths for the existing item set. So it starts with an item set and explores deeper subsets, okay, adding more items to it so that it will come into a vertical information. So diving deep into one branch of the search tree until it hits a stopping condition. Okay, so that is, the item set is infrequent. So FP growth algorithm, frequent pattern growth uses a DFS strategy. FP growth works by constructing a frequent pattern tree or tree and uses this compressed data structure to generate item sets recursively without needing to generate candidate item sets. So if it is growing, if you see, okay, so yeah, you can just see these product items, product one, product two, and support. And if you want to print the other things, you can also do that. Let's just see, we'll just go with the reverse order. Herb and pepper, ground beef. Whole wheat pasta, it associated with olive oil. In the European countries or in the US continent, they will be, maximum people are using olive oil for their all their requirement of the food preparation. So if they are going for pasta, ultimately they will go for olive oil and vice versa. And these are all the things. The pasta, we already saw this. Tomato sauce, ground beef. Shrimp, pasta. They will always, go because pasta taste is also, look like this some like a shrimp. Shrimp is nothing but prawn, I guess, right? And the chicken light cream. Yeah, it's yeah, olive oil again is associated with light cream. So whoever prefers vegetarian, maybe they will just go with olive oil, right? So again, they wanted to make a very saucy or sweet kind of a sauce, then they will go for honey. They will just add honey for this kind of a category. Okay. So let's again go back to this advantage. DFS, especially in algorithms like FP tends to be more memory efficient than BFS. So it is really, if you see the a priori, is an advantage model as it doesn't need to store a large number of candidate item sets. So FP growth avoids the costly candidate generation process of a priori. Okay. Disadvantage, search can be less intuitive and harder to prove early if you are going deep into the search tree without quickly recognizing infrequent item sets. So this is only the disadvantage because if you go and search for the longer association, in-depth association, at some point or at some stage, it is not possible. You have, you are, no, you will come to an assumption or a decision. It's the infrequent item sets it starts. Okay. Yeah, I think this is the summary, and this is what they are doing, and we'll just explore the what is ECLAT, and then we'll come to this rule, how they are setting the rule over here, and also here how they are training the ECLAT model. Is there any kind of a differentiation? Because the same kind of library, the same kind of a priori, they are importing. Then what would be the difference between ECLAT and okay. So they are just doing the list values in the rules, and that list makes a more of the ECLAT forms. Okay. So ECLAT, yeah, depth first search, it performs faster execution. Yeah, the transactions for I in range of length of DF, the range a priori transactions, minimum support, length, maximum length. That's it. So FP growth algorithm stands for frequent pattern, and it is improved version of the a priori algorithm. It is a different algorithm, but it is a continuation of DFS. Okay. So the FP growth algorithm is an alternative way to find frequent item sets without using candidate generations. Thus improving performance, it uses a divide and conquer strategy. And the core of this method is the usage of a special data structure named FP3, which retains the item set association information. So purpose of this frequent tree is to extract the most frequent patterns. So this is also they are using Python FP growth. It's a different from APY RI. That library is different and the FP growth library is different. Okay. Let's how you do.
In ChatGPT, just type Cine like eclat versus what is that? A priori. So we can easily see identify the difference. What is the mainly?
So whatever we have studied, that's how they will. Okay, so it is a vertical thing, it is an horizontal. That is the main difference. The item sets. If you see the difference over here, here it is maximum length, minimum length, conference support, everything else is very same with respect to the a priori. But the difference is they are just listing. Okay. Also, we are doing the same thing. Yeah. DFS, that is one thing. Generates candidates items is level by level, uses the depth first, you know, traversal to explore item sets directly. Horizontal, vertical requires more memory. It requires very less memory. Time complexity higher due to frequent candidate generation and scanning. Lower as it avoids candidate generation steps. Okay. Speed slower, especially with large datasets. Faster for large datasets. Many frequent item sets. Pruning mechanism uses the a priori property, downward closure property to prune infrequent item sets.
So
Uses intersections.
this breadth first, depth first. So do we need to mention anywhere in that model? Like for example, a priori we are mentioning that algorithm we are using.
Let's okay.
So the training data set only you are giving that information or something.
Yeah.
Where
Are
can you go to that code section?
Yeah. Let's see. In the transactions, yes, the transaction. Maybe I will open up one more. Query code as well.
So because the code, the algorithm remains same, that we are not mentioning anywhere like because a priori takes a breadth first, but eclat it takes the depth first. Okay,
Yes.
so but both algorithms are similar. So how do we differentiate whether it is taking breadth first or depth first?
in the previous one, I think transactions was not shown something.
Okay. So if we see the a priori model, the transactions equal to transfer the same minimum conference, minimum length, maximum length. If you see this training, transactions equal to transactions, minimum support, minimum conference. You see the minimum support level. Point to the same thing.
Oh, okay, I got it. Like rules,
Okay.
rules. Oh, rules also same. Rules equal to a priori. They are also rules equal to a priori only. Okay, but that's what I thought the difference. Okay, rules equal to a priori instead of a priori, we got put the eclat. I thought of it.
Let's take this example. Okay, but they are doing it in different way. What we will do? Okay. I will attach. We have different monitor. We'll take informations.
Senthil, I think this piece you should check.
Which one, sorry?
Putting the results well organized into pandas data frame. That is where I see difference. Rest everything is same.
So Panda data frame, I think that is a data frame we are creating.
Correct.
Okay, so but the model we need to know like whether it taking the breadth first or depth first. So since both algorithms are same, we just want to know where it applied the ECLAT, where it applied the a priori.
Correct.
Yeah. Okay.
In this, it also did not create the cluster, no?
The cluster actually we crossed actually. So this is the next stage like associate rule.
No, yesterday a priori in that it was giving us, or it was previous class, yesterday's class only.
Oh, that is K means and one more thing we say na that 1 minute let me. K means hierarchical clustering. So two things we seen. Now we move into the deep learning. Yeah.
Okay,
Yes.
just to see here. So the data representation I've given, but it's not taking that much. Okay, fine. So we'll see how the transactions has been happening. So transaction in the sense level by level. This example in a priori, this is A, B, C, A, C, B, C, and A, B. This is one transaction. But here in ECLAT, converting to vertical format, that is A belongs to 1, 2, 3, the value, the B belongs to 1, 1 3, 4, C belongs to 1, 2, 3. So this is maybe, you can try with the transactions over here. This is ECLAT. Maybe these transactions we need to visualize. Maybe open up your, maybe you opened up. Maybe after this, visualize. Okay, visualize. Maybe you can visualize this piece of information, how it has been uh, read after the training of ECLAT.
Same, Srinivas.
Same.
Yeah. I just opened it.
Yes.
1 second, I'm opening.
You just mention any ECLAT Sini in that
No,
algorithm
nothing,
model?
nothing.
Nothing, yeah?
No, nothing. No, there is nothing.
Oh,
See here,
okay.
even in the data frames, they are just product 1, product 2, and so forth. They are doing left hand side, right hand side. That's it. The columns. What they are making over here, same thing. Just supports.
Just on data
Just
frame, that's it.
yeah, that's it. That's one data frame.
Even you the terminology they are using same here. Support.
Same.
Support.
They never. So only they
mm,
are just showcasing the
okay,
difference
it's
in
might
also.
be different from the what is the data representation only.
Yeah,
So
only that differentiation. We couldn't visualize over here. That is the problem. So here the transaction they have given, right? Transaction equal to transactions. Maybe just to see in the range. Range is also same, right?
yeah.
I think so.
Yes.
Range is also same.
Header,
The transaction is here. The transaction make more sense.
Only thing is, in the results well organized Panda data frame, you can see
That's it.
confidence lifts.
Okay, so let's. Okay. E flat. Go with media. So we know the basic analysis, equivalence class history, and bottom up, that is practical example. Yeah. Milk, bread, eggs, milk, bread, diapers, milk, beer, chips, bread, diapers, beer, chips. These are all the information. So, especially generate larger item sets. Difference between that's we know. If you have to use a depth, okay, bread, scalability, that is the information. Yeah, I think during the transactions itself, they are making the smart move, the transaction one. Maybe in that, whatever we have the code, that is also not been mentioned in the
Just to
transaction one.
check the range value, see how the range you are calculating from the what is that a priori and eclat. Just cross check the transaction, the data processing, pre-processing is there now. The data
Same
pre-processing stage.
data
So
set,
can we cross check that
range zero, same thing.
processing?
Same.
Same, huh?
Same.
Okay.
Replica
I
of the
never
code,
change it.
the title is
Mm.
changed.
Yeah, might be.
Right.
But
Right.
maybe what you do, just run from your end. Because
Yeah, executed.
you ran the same. You
Yeah.
got this only the product one, product two support.
Yes, product one, product two support. That only I got.
Okay. I got this one equal to 10. How the M would be here? Yes, the same. Okay, so we'll check. Even we couldn't find much difference between over here, ECLAT and API in these explanation. Three concepts. Maybe we'll check
Suppose
it.
if you think like what is that? It consume more space or something. At the time, okay, I want to go into the eclat. So how do you what is that? Put that eclat algorithm. Since algorithms are same, I want to differentiate. Okay, just go with the a priori. So it take consumes because it's go level by level, right? It's not each transaction it will go. Not like one pick one product and go into the vertical. It's not like that, right? So so how to differentiate that way?
Yeah, they are using PyECLAT. So
Eclat.
yeah, the methods are there. And then FP growth they are using. I want to set something. Let's see how this is working. Repeat me. You want to see the code, right? Let's see this. Otherwise, we'll take it as because I couldn't see any difference between the four, so that is not the right case. So what he has done, ability to use associated rule on it. Which product display icons. This is a different data, I guess. Backgrounds, born data pre-processing, data type. And this is subcategory. Okay. This gender data set of if we are, we don't want to, we are not interested in this. Okay, training association rule modules. Both they are training. Let's see. I think this is the nice information that we have. So this is the a priori. It's the next one. Okay, this is fine. So this is an implementation of the eClat float by hand. It calculates the pairs that have been bought more frequently comparing to other pairs. At the end, we expect to see what is the most common combination of products during the week. An extension of the code can calculate the three most common combination, 4, and so on. Getting the list of products bought this week by all customers, so items, range, and same thing. Unique items. Okay, there's neutral unique. Creating combinations with the items or pairs. And what would be the pair? Names, pair, users, whatever. Okay, this is the combinations. The first is nails with combination, and then top wear, and then unisex, and then bags, eyewear, skin, watches, water bottle, and so on. Okay. Let's see the calculating the score. The calculation is done looking at the number of customers that bought both items and divided by all customers in the week. This calculation is done for all pairs possible, and the score is returned the score. Okay, that is the formula from where you are training. Okay. Ranking eClat. Okay. So the eClat is, it is not that much difference, compared to a priori. The difference is in the transactions. I mean, if it is in horizontal transactions we are focusing on, we are just keeping those informations. If it is in vertical format, then we need to do the some calculations based on the transactions. So everything is based on the transactions, inside the data set. So a priori, it is with respect to the columns, it is in depth within the column. Maybe proc transpose, how the SAS programming works on proc transpose. Similar, I think the similar kind of an approach they are approaching with a priori and eClat. So a priori is a normal transactions. Maybe eClat is a proc transpose information. So each and every product and how they are just comparing with the other informations. Top wear apparel and what would be the score, right? I think this is really, yeah, I think you see the transpose. Nothing in the code or nothing very difference in the information, or nothing more difference in the, I mean, in applying the libraries. The same API, the same thing. A priori also the same thing. After a priori only, it is we are doing eClat. So only with respect to the transactions, we are showing this kind of information. That is why we are saving so much of space. We are not running the full kind of information, so that it occupies entire space. So it is not. What if we do that for drivers? So we can. I think this is one. This one is really. Okay, I will send you this. Maybe you can. Try, yeah. I think you. I mean, I got. I don't know what they are doing. Especially, they are doing the transpose at the end of the process. That's it. So I think it is kind of a manual process. It is not a automated process. After applying the training of a priori, they're just um, putting the data format into a product-wise information. Okay, so in this product, say for instance, in what kind situations the prop transfers is working in SAS. If you just see those information, then that would be the E-CLAT information over here. Same thing.
So basically, it won't automatically transpose. That means normalized to
No,
non-normalized.
no.
Hmm?
It won't.
If you, for example, the market basket, what is that?
Mm,
Excel sheet is there, no? So it is
mm.
horizontal. All the transaction in the horizontal way, right?
Yes.
So it's level by level. So if I feed that data, so if I want to apply that E-CLAT, so do I need to transform that into one separate sheet and then feed it, or how actually the
Yeah,
process it?
here, what they have done, they just rename each and every place they want to. So if you just closely look at this information, as Sai said, they have done only the difference over here, how they are portraying the information. That is the E-CLAT information over here. So if the product one, right, supports for whatever the information you are getting, even you can just
Yeah.
take a look at the same
So
thing. Even this result is same thing. Okay. But here
no.
they are just is this the result is changing? Is this result is changing from the
No. That is
API?
the result changing. Yes.
Ah,
But
okay.
what I did is I just copied the whole code and asked ChatGPT
Mm.
to explain or perform this code in a priori model and
Okay.
explain the difference. What is the
Okay.
difference? Where it is the difference it is showing. So what it
Mm.
says, let me share my screen.
Okay. Now we share. Mm.
Can you see my screen?
Yes.
Okay. So if you see here, the same code I just copied. My question was, show a priori code for this and explain how different it is.
Okay.
So the code you said for training an E-CLAT model is actually based on a priori algorithm only, rather
Mm.
than E-CLAT.
Same algorithm.
That E-CLAT algorithm is different from a priori, although both are used for association rule mining in market-based analysis. So here is the breakdown. A priori generates frequent item set by using breadth first. This is the same logic he's saying. But the algorithm utilizes support, confidence, and lift in a priori. In E-CLAT, it will not be used. So these three, if you see our code in the pandas last
Mm.
this thing.
Data frame.
So if you
What
see
is the
there, here,
mm.
support, confidence, and lift is not utilized. So that is what he's saying. Code explanation a priori. From a priori, minimum ensures the only frequent item sets that occur in at at least 0.3% of the transactions are considered. Minimum confidence ensures the rules with at least 20% confidence are kept. And rules lifts at least 3 are considered, where lift is measured of how much more often the items in a rule occur together compared to how often they would if they were independent. Limit sizes of the item sets. The results of these rules are later converted to a data frame to display them in a well-organized manner using inspect. So inspect function to extract the LHS and RHS and support of the rules.
So we
Here,
use support. We used to support.
support of
But
the
the
rules.
confidence and lift is not used to here in the E-CLAT.
Yes.
So differences between Euclid and a priori is breadth first search algorithm uses support, confidence, and lift to generate rules. Generates candidate item sets iteratively and then checks their support. Euclid depth first algorithm uses support to mine frequent item sets, but does not directly generate association rules like a priori. So the
Okay.
difference is here only. The
Not using that confidence and lift.
confidence and lift.
And lift.
With the code which we are using, approaches might be different, but I tried to check the code which we were using, both were looking same. So what is the difference? So as discussed, like this is the portion. So if you see here, this one, and if you see this piece,
Can you, so for example, you copy that conference lifts and paste it in the Eclat and run, whether it will able to run that part?
it will throw error. We have to add these into this one as well. We can add 1 minute. Let me copy the whole thing. This piece, right?
Conference lift.
So everything is same now. I'll copy from here.
So the conference lifts. You have to add one more copy that previous from a priori, that resolution data frame. Resolution data frame.
We already gave you. Okay.
So it is coming. So
Items are changed until you see. No. Yeah. There is a slight difference in the items.
even value also, right? Support. See, for example, herb and pepper and ground beef. What is that? 0.
Value is
Value same.
same.
Support is value same. Conference.
Maybe take out for different use cases, then just try to identify where it makes more sense, so that you can see. So, to my knowledge, during the, I mean, we are not explicitly transposing, but in my example, what we have taken, that we are taking the transpose. But at the same time, what they are doing, we have converse. So then only
Because we are not changing any what is the transposing or anything in the pre-processing stage. Just we feed the data. We just feed the data.
Yeah. We are not doing anything over here in our code, in
Yeah,
our example.
correct.
Nothing.
Yeah, stop sharing.
Okay. Maybe you can just analyze.
We just will what is it? Dig into that. Why the difference? What is the main difference actually?
Right.
Eclat
So I've shared one code, right? So okay, you can go through.
In GitHub.
That GitHub, yeah, I've shared that. That is really an interesting one. Both they have discussed. It is really a different, use case. Right. So this is all about association learning. Then
where is the full code to download?
No, you have to download the zip code.
Zip,
Zip file.
yeah,
Only you have to
to
download.
find the zip file.
Maybe what I will do, I will just send you this code.
Just send the link, Sini. Yeah, we will download it.
No, I have already sent it, but
Already sent,
I will
WhatsApp
send
it.
in WhatsApp. Okay, even I have sent the code. No issues. Just import it. I mean, download it.
Mm.
It's a really wonderful. Right.
APY ECLAT, right?
Yes. Right. Fine. We'll go through what is the next one. Reinforcement learning. Okay. In reinforcement, there is upper conference zone, and there is one more thing called Thompson sampling. Okay, upper conference zone.
These are all comes under unsupervised. This.
Yes, unsupervised.
So start from what is that? Clustering all are unsupervised.
Yeah, mostly yes. Confidence.
So till okay. So basically, the deep mining, that unsupervised model will start from association rule learning, part 5.
Yeah.
So 1 to 4, like it will be a what is supervised model.
Yes.
Till clustering will be a supervised model. Correct?
Yes. Yeah, right. Even within that one, yeah, I think till yes, that is also supervised. And these are all the unsupervised. Okay, we'll see an important algorithm now, which is called as
Nini, you have not shared the file. Okay, I'll download from.
where?
No, this tiles CSV file is required. No?
Oh, okay. But it is already inbuilt, right? Maybe if you, I mean, just go to the GitHub. You'll be able to.
Yeah. That one. That is what I'm opening.
Okay, but this file is not working. It seems. The style sheet or the graph. That's what you are saying, right?
No. The CSV file is not there. So
Okay. You
that
have
is
to
what I
download.
want.
Input
Yeah,
input data.
the input data you have to download.
Hmm.
Okay, I think the reinforcement learning.
Good data is not coming in this.
Okay, so let's. Okay, so after this reinforcement, we'll maybe I will try to send the data separately. Because in that link, if you go, is there a data set?
It's qualitylifemedium.com only. No. There is one more GitHub you have sent. A priori GitHub, efficient a priori. Next one is a priori and ECLAT.
Yeah, the third one. I mean, yes, third GitHub. That is the.
This has only one file.
Okay.
The link which you have shared has only one file.
Yeah, only one file.
Yeah, IP by NB.
Yes. There is no data. No, they have not
Data is
uploaded the data set.
to execute the program.
Maybe we'll try to. Maybe they will be giving. I mean, they have sent an a note where you have to download. Just look around the GitHub in README file or wherever the file or wherever the information. Just look around. You will be getting the information. Okay. So this reinforcement learning is one of the most fascinating fields of machine learning because it drives a lot of things. Without reinforcement learning, we never use some of the applications. And reinforcement learning is one of the critical and also at the same time it is one of the life use cases. Whatever we think, we are getting from ChatGPT, we are getting from the other large language models, not only large language models. There are other applications right from your chess. Okay, gaming technology has been improved because of reinforcement learning. Okay, so how, what, when, where will going to see. So it stands out from other types of learning paradigms as it focuses on agent learning to make decisions. This is where the agentic AI process or AI agents processing comes in. Agents in the sense the smart agents like chatbot, even whatever you are using. Um, ChatGPT is also one of the biggest agents, agentic AI model. Your Google search engine is one of the biggest agentic AI process. Likewise, if you consider any kind of an automation process, they are using different algorithms, that algorithm learning by itself, then those things are, we will be calling it as agentic AI. So that starts with reinforcement learning model. Right? The focus is on agent learning to make decisions from its actions and rewards in an environment. If the action is executing properly, it is getting reward. It is not executing properly, then they will be getting some kind of a punishment. And from the punishments, it will just getting some kind of a learning. And then next time, next iterations, it will be giving the I mean, even the ChatGPT also, maybe if you are asking very vague or something, first time it won't give you a right response. If you are again asking something, it will be saying that I was not giving the result properly. That means it is punishing. Okay. And if it is the information it is getting really nice, then it is getting rewarded on its own. Okay. So this is what we are going to learn. So the reinforcement learning is an aspect of machine learning where an agent learns to behave in an environment by performing certain actions and observing the results and rewards and then results. Okay. So the agent learns to achieve a goal in an uncertain, potentially complex environment. Okay. So in RL, an agent makes sequential decisions while interacting with an environment with the aim of maximizing a cumulative reward. Okay. Here, I wanted to ask you one thing. Maybe I think if you have discussed before, just let me know. Otherwise, if you are downloading for the first time the chess game. Okay, so before going to see any other game, we'll start with the chess. Okay, so if you are downloading for the first time and you have started playing the game against the computer, okay. So what would be the winning percentage against the computer for the first time?
Human will win now.
So for the first time, there are more chances of you win the game, right, against the computer. And the second, third, and so on, it is very, very difficult that you win against the computer. Have you observed the situation? Have you observed?
Yes.
Okay. So what is this? What is this happening? Why you are winning for the first time? Why you are not able to win for the next and so on? It is very difficult or it is very challenging for
Maybe
the next.
they got trained on the different approaches, right? They might not be trained on initial stage, but after that they will reinforce that being learn on by own and approaches what we are thinking able to guess it actually.
Sai, what is your response?
For chess, sorry, first time it does not know what our approaches would be, or it will learn our moves based on that. Second time, it will try to improvise based on our moves, and it will try to understand how we are thinking, and then it will proceed further.
Yes. So for the first time, it learns your pattern, it learns your behavior, it learns your approach, and for the next time, why we are not able to win, because first learn by all its mistakes, and then it is getting punished, and then it is giving lot of things, and as it is having some potential of calculating the moves faster than you. Okay. Faster than in the sense, if you are just thinking, see chess, how we will play. If we just take out the first move, what would be the first move of the opponent, or the second move of the opponent, or the third move? At least four. And the normal human being, I'm thinking. I'm not talking about the prodigy or somebody else. Okay. Uh, Normally, okay, if I take this, if I move this, if I take this move, then okay, the next step would be, or if it is not the next step like this, then if it is the second step, second move like this, and so on. But the computer has its own power, the computational power depends on that. Even it can, understand, like, there may be 100th step, 100th move, or 80th move, or and so on. Because it is the calculation, right? We have the algorithm, and that is the power of the algorithm, that is the power of computer as well. And we couldn't think, we couldn't imagine in that fast movement. And I'm just not talking about the average human being, even the normal human being. Okay, so that is the basic of reinforcement learning. So it is reinforced each and every time of the execution, and it is getting learned. And now imagine if you would have played any 3D games, any kind of a shooting games, any other creative games, right? Why you are not, you are trying to win, and it is engaging, it is just entertaining, and it is always push you to the gaming environment, because it is continuously learning. That is also one of the processes. Continuously learning by the input you are giving, or how many players are giving. It is just taking, and it is and you are creating one computer image, the opponent image, and you are just against playing with them, and you always try to win the sequences. But that is the environment make more interesting and engaging. That is called as a reinforcement learning process. Okay, so here let's just see the first I will share this link. Perfect. First, the input raw data, then the environment, the agent. Agent starts from the selection of algorithm, right? This is the environment, and if it is going very smooth, it is getting rewarded, right? And it's just again doing what it is. And if it is not like this, then you are going with the output of we'll just explain each and every output. The agent will be the decision maker or learner. Environment, everything outside the agent interacting with it. Section A, what agent can do, the choices it has. State the current situation returned by the environment, and the rewards, immediate return sent back from the environment to the agent in response to its action. Okay, so this is what a slight approach of this reinforcement learning approach. Once you get the reward and reward and reward, it is always the training could be more and more and more powerful. Like how we are asking a lot of questions to the chatbots, questions to the AI chatbots like ChatGPT or any other. ChatGPT is it's just a common ways of asking questions. Likewise, there are so many chatbots are available, AI chatbots are available, and those environment and how you are utilizing for your personal use or personal growth, enterprise growth, or any other growth, or you are improving your skills of asking questions, the prompting and everything. So if the prompting is not right, then as a human being, you will not be able to learn or something. Maybe that piece of information, that's a separate information. Okay. Just we are only talking about the learning process of the machine. We are not talking about the learning process of human being. Please, have the differentiation. Keep this differentiation in your mind, and then you approach the machine learning. Okay. So the application, yeah.
One question, Srinivas, like now chess is a two-member game. The probabilities it can be worked out based in the combination of the pawns you have and everything. And it will learn based on your moves and then it will play. My point is like when you are trying to play games like GTAs, for example, GTA 5 is there now, GTA 6 is coming. It is based, that is also based on MI or this thing. Based on your play, the game course changes. For example, there will be three characters, and you pick one particular character and you choose one path to move. The, the way you progress based on that, the storyline of the game changes. So that also will be implemented using this process or reinforcement of learning, or it is like um, there are set concepts uh, based on characters. If you take this part, this will come. If you take this part, this will come. Or that also is based on ML.
Yes. So see, basically there are combinations of machine learning and combinations of NLP. The deep learning as well. So the basic concept or context is reinforcement learning. That is one we should understand. The next thing is maybe multiple AI agents. The agentic AIs would be there inbuilt, so that the story just built in progress. And also, if you are changing your moves, accordingly the story will change. That is what you are trying to say, right? Accordingly, the game will change. So that is also based on the basic concept is reinforcement learning. But if you are using that kind of a context, maybe 3D games, so the entire story just changes. In those lines, they will be taking this as a foundational model. But there are advanced models which compared to reinforcement. But the basic model and foundation is reinforcement. So maybe they will keep on. Now we just crossed more than 20 algorithms. Okay, now we are seeing reinforcement. Okay, so
Yes.
whatever the possible ways of likewise, if I see today we are seeing about reinforcement. Maybe tomorrow we'll be seeing about the computer visions. in that computer visions, how the reinforcement learning model, which provoke, then based on that, the libraries will change, the advanced libraries will change, but the foundation is same. Maybe you can see the advancement of algorithm processes, but the for basic foundation in all the elements on wherever the reinforcement learning uses, this would be there. Even if you are using NLP, foundational thing would be the reinforcement learning. I will show you one. We have asked some kind of information, right? And they have improved this many years, 2 or 2.5 years. They have improved, like you can give audio. You can talk to this, and you can also copy, and you can give whether it's a good response or a bad response, and also you can switch the model. These are all it came after a lot of time, and these two things already there. Okay. This means, is it a good response means it will get rewarded. If it is bad response means it is now I have given this as a bad response because this is not giving with as per the sheets. Just I have just copied. Maybe there is a mismatch in the IP and the extension or the file extension, whatever it is, right? So and now they have given lot of information as well. This is one of the classic example of reinforcement. So because it is trying to learn more about our responses based on the human giving the responses, and if it is bad, then it wanted to analyze what has been made, what has been wrong, and the response has been wrong. What would be the reason? So it will go and search for the reason. It will go and search for my prompt. And if that prompt and this response is not matched, then ideally the bad response I have given. Now the next time if I ask, it will give the response like I could not process the Python, .ipynb file, or I could not process a PDF, or I could not process a document, and so on. That means that is the right response because it is clearly telling me I couldn't process your request. So I have to ask within that boundary. Maybe you have copy paste the entire code and you have asked. That might be the tedious process. What I thought. Okay. So why I need, and there is an attachment, and I'm trying to give something. So this is also one of the response. Likewise, whatever you said, that is also based on the basic, reinforcement. But I said this is the classic example of a reinforcement methodology. But when it comes to the whole kind of a response system of ChatGPT, they will be using multiple things like the advanced thing is transformers. Okay. So the pre-trained model they were using, there are so many things. Maybe there are combinations of machine learning, there are combinations of deep learning, there are combinations of NLP because they introduced this voice response system too, right? So there are multiple things, and you need to observe going forward. Which what, what, where the differentiation could be. Is it going to be the single-handed machine learning or multiple algorithms they have used? And if they are using multiple machine learning or deep learning, then what would be the output? So you have to start observing this kind of things. So here the agent's objective is to learn a policy. Very important. Okay, learn a policy, which is a mapping function from states to actions. The policy determines the learning and decision making, telling the agent what to do at a given state. So we have to give the clear policy, and based on the policy, it will learn. So if you are just trying to play a chess game, the rule has already, the rule or policy has already been trained. Okay. And in that trained model, for the first time, maybe I will give this example. Maybe for the first time you have bought the Alexa product. I'm not sure whether you have or not. If you bought Alexa product at your home for the first time, maybe for the first week, the responses from Alexa would be very, very clumsy or very, very confusion, you know, uh, maybe confused state at that point. Because though Alexa products has got trained on multiple things, for the first time you don't know how to operate. That is one thing. And the device doesn't know what kind of questions you will ask. Just see the situation, right? This is the classic example of reinforcement. And for after 10 days, it will learn your pattern. Not only you, whoever is asking at your family members in your family, just try to absorb things. And then maybe if your kid asks nowadays, what is happening, it is trying to differentiate the voices. For that, it will ask you, who are you speaking? Please tell me your name. And if you tell your name, it will just store. And it will next time, it will maybe I ask questions and it will just ask my name. I have given my name, Srinivas. Next time I'll ask the question, it will just talk to me like a friend. Okay, hey Srinivasan, this question, for this question, I don't have a respective information. Maybe you can try this or that, and it will respond. And also it tries to understand your family members' voices. For that you have to set their name. Okay, and then for the next time they will ask, it will for sure it is just trying to identify and trying to speak like a friend. Okay, even if you say age range, according to the age range, it will be calling you. If it is a kid, it will be interacting with the kid like anything. Maybe you can go and see the difference if you have the. This is
Yes.
this is also a reinforcement plan. That means it slowly it just process your request, and at the same time it slowly records all the time 24/7 whatever the communication you are having at your home, right? And we are thinking that it is not recording. Maybe only after the requesting it is recording. No, it is always recording. Okay, maybe you can also check or you can also observe that during the conversation, if we have any kind of an English word, it will pop up and it will just trying to no, sorry, I don't know the context. Those kind of things also happen, and I experienced that. Okay. So this is a class. I mean, it is not. I mean, it doesn't mean that only reinforcement learning has been implied. No, but it is a major portion. There are multiple other machine learning and deep learning methodology also was trained, and majorly reinforcement is there. So going forward, please observe these kind of observations. Even if you are going outside, nowadays malls, not only the HD cameras installed, that is also an AI, smart cameras has been installed nowadays. Even in your office, if you just go and you don't want to punch or something, even ID card, nothing. If you're just being there in the camera and it automatically captures and it will automatically put the attendance. Nowadays, that much improvement has been made. That is widely used. Okay. So that is also one of the informations of reinforcement learning. So it has a wide range of applications spanning across various fields, game playing, variety of games, including chess, Go, poker, AlphaGo, developed by DeepMind, defeated a world champion Go player. See, AlphaGo by DeepMind. DeepMind is from Google. Okay, so this is very famous game. Even IBM is having IBM Watson. That is also one of the reinforcement learning games. And robotics. RL can train agents to perform complex tasks like walking, running, or jumping. So Boston Dynamics robots are great examples. So slowly you are getting into the, that's what I said, slowly you are getting into the deep learning module. Self-driving cars. RL can be used to optimize the decisions made by autonomous vehicles to improve safety and efficiency. Online advertising. RL algorithm can decide which ads to display to users to maximize click-through rates. So yesterday Sendil was saying, if he just moves to different location, there is no offer, there is no nothing, no, because that is the RL algorithm. Okay, so we are thinking at that algorithm, no, at that point in time, we are saying something. Yes, that is also there, and mostly this is also there. And then
So
how
now-
automatically? Hmm.
Now that concept what Senthil spoke came in clustering. Now
Plus,
this
yeah,
is learning.
yeah, that's
So
what. So both of them are available because see, you can't manually interrupt the informations, right? How the
yeah.
application that is why applications are becoming more costlier or expensive because we need to have that kind of a space, that kind of an infrastructure. Otherwise, we can't see everybody can. I mean, these days, just a 5 minutes, matter of 5 minutes, we can have the application. We have seen that. Amazon Party Rock, one of the classic example. Within 1 minute, you will create an application. Then what can stop us making as going for the public? Because we should do a lot of other things as well. So if you are going some other place, right, it should automatically change. It should not be all the places it has to be like this. Then your model of business will fail. And then recommendation systems. So RL can help to provide personalized recommendations to users. I think in I mean if you are Swiggy or Zomato users, even for any other applications, um, the message will pop up if you are Zepto or Swiggy users. Swiggy mostly. Swiggy users. Maybe at the time of 3 p.m. Along with your name, the funny quotes will appear, funny elements. It will be really interesting. Okay. Okay, samosa is available. Samosa is special from this restaurant, or any other snack, the local snack nearby area. Okay, it is very you just go and have the snack and go forward. Likewise, the storyline it will be given, and by just seeing, it just keep on refreshing. Okay, so because food is very very important for us, right? Uh, uh, yeah, at the 3 o'clock or 2:45, it will give some telephone alert, right? Keep engaging, and just giving some information. Okay, so and not only this application, every even Zepto, it is giving, even Amazon. This is a customized recommendation through email, through messages, through alerts, pop-up messages. So it is that it is automatically given along with your name. It will be coming. Just observe, clearly observe. Okay, so this is also the recommendation system. Also, one of the key part of RL, and we have seen a lot of recommendations algorithm as well in previous. That is also there. So don't get confused. Okay, so hereafter, you will be getting confused so much. So what would be this algorithm, that algorithm, and where it will be used? So this is we are in the middle of machine learning and deep learning. We are close to open up the deep learning processes. So you will get confused, and it is good that you are getting confused. Then only you will get a very clear idea where to go and what to go and what to select, where to select. Okay. So just keep the confusion open and note it down, and you'll be getting clarity once we are going in depth of deep learning processes. Okay. Learning from their past behavior to suggest relevant future actions. Okay. So this is very simple explanation of reinforcement learning and what else would be there. So we'll see next week or next week. Next week we are going off, right? Next week.
Yes, Srini. Yeah.
Okay. So we'll see after the next week. So from this reinforcement learning, slowly, we will be. Yeah, I have to teach you one more knowledge base. What is knowledge base and storage system and everything, and that is a theoretical part. You have to listen. There is no other way. Then only we will be able to understand the artificial neural network. Yeah, those things should not be here. So we'll be discussing about other things. Yeah, in deep learning, ANN, CNN, and natural language processing. Even for natural language processing, I have to teach you the knowledge base. What is knowledge base? Where the knowledge base is getting stored, and yeah, and then the dimension. These are all the very deep, in-depth deep learning process, model selection, and this is about the optimization techniques. So don't get confused. Only this, we are going beyond this, okay? And we have to. And apart from this, part 10, apart from this, there are 5 more algorithms are there. That is also getting covered, and GenAI. So GenAI will be the last module that we will be going to see. Okay. Right. So by this, I stop over here and get ready for the reinforcement learning. So the reinforcement learning, you will be, without this, there's no other application you are using right now. None of the applications exist.
So first initially is learn by mistakes. Yes. Then going one by one. It's a point of continuous learning. It will work.
Continuous learning. Yes. Learn by mistakes and also learn by rewards. Rewards in the sense, if it is correct, it is getting more and more efficient.
Even like many banking sites or something, once you finish the transaction or something, it will on your logout immediately ask you to fill some feedback. Okay,
yes.
Whether it is exceeds something or something, it's outstanding or something. No, so if you feed that, it is taking it as a reward, and then try to give that information next time, right? So all the applications are inbuilt with that reward system. Whether it is successful with the rating, everything it is automatically generated, right? So learn on by one, we mean to say.
Yeah. So that's how the financial applications like market analysis applications, market trends, share market trends, share market financial advisors. There are so many applications that developed recently. They are giving you a very the futuristic aspect of where to invest, how to invest, which fund you need to go for. There's so many things, but still, the more okay, to some extent it will work because we are playing. It is like a gambling again. For financial market trends, we never judge, but to some extent we'll judge. So going forward, it is really,
it is like somewhere we feel like infinity. So infinity, it's not. There is no end loop. It's going and going. Where to stop learning? I don't know. This is where we have to create a boundary. I'm trying to create a boundary. Okay, within the boundary, we'd like to learn something. No, it is not like that. It's going loop. It's very difficult to set our boundary.
Maybe what did you think of initial stage? Maybe I think both of you. Okay, so these are the set of algorithm. Okay, that's it. We learned AAML. Maybe you would have thought. Actually, it is not.
No, actually, we had a mindset Okay, till we have supervised model now. Okay, this is a center, everything. So mindset is created. Okay, we are going in that direction. But yeah, any model now. Okay, first train, test, and then we have to see the result. Okay, we can go. Once you go into the unsupervised model, now everything collapsed now. So now I'm thinking, okay, whether we are on the right track or going back. Something little confused, but anyway, it's like looks like confusion matrix.
Yes, yes. So you will get clarity after applying this technique.
Yeah, learning is always on. We will actually face the problem, or you will actually find the problems when you're implementing into a project. That is where
Yes,
your
yes.
actual learning happens.
Yeah, exactly.
But before that, I think we know what is the fundamental. That's a very important. That's a key point here. So how to, even if you problem statement also, making a problem statement is not an easy thing. So create a problem statement and moving towards the solution. That will be a different journey altogether. But for moving to the journey, we need some fundamental, right? So without fundamental, we can't build anything on that. So we are just trying to learn the fundamental now. Okay, different algorithm is there, different stints is there, how to apply that algorithm to get the particular stuff. These are the different things.
Yes.
We are just observing. We are not very deep into that model. We are, as you said, if you go very deep into that any model, we become so crazy. Like we can become more. What is that? Either we are going to statistical, because we are not coming to the real world most of the times. Because when we go very deep, it will take you into the technical aspects, like how to debug the code, how to check this. Because we are spending most of time in the things, but we lost the track on creating the idea. So here, idea is the matter. That's what we need to understand very clearly.
That's why I can identify the problem statement.
Yeah, that's true. But technical also very important. But the thing is, it will pull you into that direction. So we go deep into the technical. You start learning many things, and it is keep on pushing into that direction. But somewhere we have to stop and think from the business perspective too. That's what.
Perennial thinking should built in.
Anyway, business magnets are there, so I'm very glad. Sit in front of the business magnets. So it's
be
attracting
ready
some forces are attracting towards me also.
So be ready with the project ideas. Be ready with the project ideas. We have to do the projects.
Okay, Sini. Yeah, we will start thinking about it.
I will never leave you without doing the project.
Yeah, we will definitely do. Yeah. Sure. Yeah. Thanks, Sini. So you just shared the videos. We'll download. Okay.
Yeah,
so
yesterday I shared. Today's I will share.
Yeah. Once we download, we'll let you know. So the next week we don't have class. So another week we will schedule them. We'll plan accordingly.
Yeah, sure.
Week means 1 minute. What is the date? Next week is 11/12.
Dasara time. Saichen. Yeah, we're planning thought of Monday, Tuesday, but we have symposiums, right? So it's very difficult to accommodate. Okay. Okay, Zini. Yeah.
Thank you.
Have a wonderful day. Yeah.
Okay, you too. Bye-bye.
Thank you. Bye.